Right, so in this video we will take a look at the iterator design pattern. Iterator is probably one that you've used. If you've used Java iterators, that's actually just a direct implementation of this pattern. So this is the Wikipedia page that describes iterator. I definitely recommend that you take a look at it. It shows you how this is implemented in C++, where there are no interfaces, and Java implements iterator as an interface. So it turns out UML diagrams, you can set up classes or interfaces. We haven't done interfaces yet, but as you'll see, it's pretty straightforward. So in Java 5, there is even an iterable interface which returns an iterator from its only method, and so that's what allows you to use the enhanced for loops. You can also use iterator in Python and PHP. They have code that shows you how you can set up iterators, an iterator interface in Python. So highly recommended, this Wikipedia article on the iterator pattern. So let's take a quick look at what this is supposed to do. What is the context for this iterator pattern? There is an aggregate object, let's say a list or something like that, that contains element objects, and clients that use this aggregate object need access to individual element objects. The aggregate object, however, does not or should not expose its internal structure. So iterators should work whether this list that you have is either a linked list or an array list or a vector. No matter how the internal data structure works, the aggregate object, like vector, should not expose its internal data structure. So multiple clients may want independent access to individual objects in this aggregate. So what do? So you have a list. It can be implemented using a linked list data structure or an array. You want to have you want to give clients access to individual data members, but not at the same time not expose the internal actual data structure used. Okay, here's the solution. Define an iterator entity that fetches one element at a time. Each iterator object should keep track of the position of the next element. If there are several aggregate or iterator variations, it is best if the aggregate and the iterator classes realize common interface types. Okay, so there's many ways to implement iterators. You should be able to set up a linked list iterator as opposed to a array list iterator, and so on. And here's the general structure. So you let's say that the aggregate is an interface. For example, in Java we use the list interface, and this should have one method among all the other methods that it needs for maintaining a list of objects. It should have a create iterator method, and so this would be, for example, in Java, that would be the Java util list interface, and then that's the way the client will interact with any kind of instance, any kind of class that implements this interface. For example, a concrete aggregator. Concrete aggregator could be linked list or array list, or what is another one? Vector. I guess vector would be another, just like array list. Okay, so client should see iterator. I'm sorry, client should see an iterator object eventually that interacts with the actual collection, which could be using an array or a linked list, and it could be a doubly linked list or anything. It doesn't matter. You have some concrete aggregate object which contains a list of things, a bunch of things, and in the end you want an iterator that will get one thing at a time. How do you do this? You set up another interface called iterator, and that's actually what the name of the interface that we have in Java. So the concrete iterator could be, for example, an anonymous class implementing list iterator in Java, and Remember that with interfaces, all methods are public, static, and abstract. And so you have things like next is done, current item, and these will be implemented in the concrete iterator. For example, it could be an anonymous class, or you could actually create a class that implements this iterator interface. Okay, so up in the aggregator, you need a method that will return an instance of this type, iterator. So you have a create iterator method that will return a list iterator interface, or actually an object. So the iterator interface has three methods: next, is done, current item, and so where are they implemented? They're implemented over here, and these two objects sort of depend on each other. So if you're not used to these UML diagrams, this means dependency. That is, this client somewhere might have a temporary variable or a parameter that is of type aggregate. In Java would be list. So that's what this dotted arrow with a arrowhead means, is dependency. The client might also depend on an iterator. It might actually have a temporary variable of type iterator, but actually create an object that is of type concrete iterator. Concrete iterator extends, or actually implements, since this is an interface, concrete iterator will implement the iterator interface. And concrete aggregate, for example, linked list, implements the aggregate interface. And these might depend on each other. That is, this aggregate will probably have local variables or method parameters of this type, actually of this type. Okay, so that's the general idea, and hopefully you've used iterators for linked lists or array lists or vectors, and so this sort of makes sense. Once again, the whole idea is you have some object which contains a whole list of things. You do not want to reveal to any client how they're stored. They could be arrays, they could be linked lists, or doubly linked lists, or stacks, whatever you want. You do not want to reveal how they are stored, but you want the client to be able to access individual elements using an interface with methods like next, is done, current item. Okay, so using these three methods, the client should be able to access any element in this concrete aggregate. And how does it do that? You have to eventually end up creating a concrete iterator which interacts with this to get individual elements out of this list without exposing how things are stored. Okay.